Hello everyone, this is Prashanth. Let's continue with the last lecture. In the last lecture, just we have discussed about IoT architecture, IoT building blocks, different types of building blocks, and along with the functionalities of the building blocks. So let's continue with the IoT reference model or ARM, IoT reference model and architecture here. So the reference model and architecture, the basic block diagram of reference model and architecture here. So this is the just IoT reference architecture that describe what is the main function. It describe essential building blocks as well as design choices to deal with the conflicting requirements regarding the functionality. It is functionality, performance, development, and security. So these are the main functions of requirements: functionality, performance, deployment, and we can provide some security protocols to us. So the interfaces should be standardized best practices in terms of functionality and information usage to need to be provided. So these are the main functionalities of IoT reference model and architecture here. So here this is under reference architecture. It is architectures under actual systems here. So the relationship between a reference architecture and actual system. So this just that is figure denotes the relationship between a reference architecture. What is reference architecture? So completely in place of some diagram, just we have to denote reference points. So with the help of reference points, we can describe the entire process of each domain. So that is reference architecture. That is architecture. This is existing model in between the architect and extracting essentials. So from the original, just we can extract the original features. Next, in the architecture, we have just constraints, opportunities, feedback, like that. So in actual system, we have real-time applications like in mobile, in graphical field, like that. We are denoting actual systems will be occurred in the real life. So these are the just introduction points of relationship between reference architecture and actual systems. The relationship. Next, architecture points here. So the central choice of the IoT architecture project was able to basics work on the current state of the art rather than using a clean slate approach. That is first point. Next, due to this choice, the common trends are derived to form the baseline of the architecture difference model. That is next second point. So this has the major advantage. What is the advantage? Advantage of ensuring background capability, compatibility of the model, and also the adoption to established working solution to various aspects of the IoT. So with the help of end users feedback, already existing holders like end users organized into stakeholders group, new requirements for IoT have been collected and introduced to the model building blocks of the process. Next, this work was conducted according to the established architecture methodology. That is the last point. So these are the points regarding actual reference of reference model IoT architecture. So next one, IoT architecture tree. So here a reference architecture that is visualized as. So here IoT architecture tree. So here these are the communication protocols like RFID, Bluetooth, Wi-Fi. Just we have to develop communication between the IoT associate devices. Just we use communication protocols like Bluetooth or Zigbee or Wi-Fi, depends on our requirement. So from that we have sensors, actuators, in order to gather the data and analyze and send the information from source to destination. So for this we have different domains like healthcare domain, productive business environment development domain, and logistic domain, smart cities, smart houses, smart transport, ambient assistant living, smart energy, and the retail system. So these are the different domains of applications of IoT architecture reference model with communication protocols and IoT devices like actuators and sensors. Next, reference architecture can be visualized the matrix that eventually give birth ideally to all the concrete architecture here. So, for establishing such a matrix based on a strong and exhaustive analysis of the state of the art, we need envise the superset of all positive possible functionalities, mechanisms, and protocols that can be used for building such concrete architecture place to show how interconnections could take place between the selected ones. So this is about IoT architecture tree along with some communication domain application domains with communication protocols. Next, start with IoT architecture reference model rationale. So it is the main building blocks of IoT architecture reference model building blocks. So here it can start with the existing architecture solutions like real-time solution like ASPIRE, Sensi, like that. With these are the existing architecture and solutions. This can be SOTA with IoT architecture reference model. So here in Vision we have business scenarios and stakeholders or end user feedbacks also it can take, and IoT reference model and IoT reference architecture. Reference model is different to IoT reference architecture also different. So with the best practices, it have multiple organization with not only deal with a single organization, it can deal with multiple organization within the area, and the implementation on new IoT architecture. So this is the IoT rationally reference model building blocks. So IoT reference model it can provide highest abstraction level for the definition of the IoT architecture reference model. It promotes what is the main function IoT. It promotes a common understanding of the IoT domain. The description of the IoT reference model includes general structure, general structure, uh, general structure, general structure. It can reference model includes general discourse of the IoT domain. An IoT domain model is a top level description, and IoT information model explain how the IoT system going to be model. So this is the IoT architecture model rationale with including some existing architectures and solutions, vision, business scenarios and stakeholders, IoT reference model, IoT reference architecture, multiple not only single organization, it can deal with multiple organization, implementation on the cloud, so like component IoT architecture. So this is the ARM rationale. So IoT reference model provides it can provide which type of functionalities to human beings. So it can provide highest abstraction level for the definition of the IoT architecture reference model. It promotes which type of functions. It promotes common understanding of the IoT domain. The description of the IoT reference model includes general disclosure of the IoT domain, and IoT domain model's top level description, and IoT information model explain how IoT information is going to modify. So same points here. So the vision. What is the vision? The vision summarizes the rationale for providing the architecture reference model for the IoT. At the same time, discuss the underlying assumptions such as motivations. It also discuss the how the architectural reference model can be used for methodology applied to the architecture modeling and the business scenarios to stakeholders address. So these are the some points regarding rationale diagram which we discussed in the last slide. Next, to overall process of the architecture model. So the ARM architecture reference model process consists of one main process which is the ARM derivation. Within the ARM derivation, two actions are worth mentioning and visualize. So here the domain modeling. The domain modeling, which results the IoT reference model, and functional modeling, which is the main contributor to the IoT reference architecture. So here, so the main domain model IoT domain modeling and the reference model. Reference model, which is the main contributor to the IoT reference architecture. Next, this process receives the input from the requirement collection process, which in turn receives the input from external stakeholders and the state of the art surveys and non-conductor early stages of the IoT architecture. So here it is the diagram for high level representation of the IoT reference model, IoT reference architecture dependencies, and model inferences. So here it is the high level representation means what compulsory. Just we have to use in business scenarios, existing architectures and stakeholders. It can just transform into the real time application requirements. Whatever it is available in the market, that can be possible with this high level representation. So here IoT reference model, just it can guides through the IoT reference architecture and component domain specific architecture here. So the it can define with application specific requirement, unified requirement it can steal and explore to from the unified requirements explore it from the application specific requirement, that is. So it is the process for business scenarios and existing scenarios, architecture and stakeholders to the IoT reference model. So this is the overall process how the represent high level representation of the IoT reference model and IoT reference architecture dependencies and model influences. The next one, dynamic view of the IoT architecture ARM process. So here the process includes several things to develop or to review the ARM process and stakeholders. Like we have different technical and parameters here. So the dynamic view of the IoT architecture here start with technical analysis first. Technical analysis, demonstrated implementation. Next, ARM draft, ARM review. Between these best practices we have. So here ARM derivation, domain modeling and function modeling with requirement collection, information state of the art. So these are the just overall dynamic view of the IoT architecture reference model process. So including just up to now we have discussed about requirement collection, state of the art solutions, review, draft, demonstration, implementation, technical analysis, ARM derivation, domain. Just now domain modeling and function modeling also one of the main functions of the IoT reference architecture. So here this is the just under the ARM development. So the blocks are including here. So apart from this, we have stakeholders from the requirement collection and state of the just we have to collect some information, and upon that we have technical analysis and demonstrated implementation. So here just within 4 points I will conclude this dynamic view of the IoT architecture reference model. So the ARM draft viewed by the project's external stakeholders, the demonstration activity as well as the technical work packages. These review serves as input for revision of the ARM process. So here the first point regarding ARM draft and ARM review. Next one, the work in the ARM derivation process is presented and the ARM draft only. The initial ARM draft 0.09 versus presented in the delivery of D.1.2. Next, ARM draft is reviewed by the project sectional stakeholders, the most activity, the review process as the ARM process. So besides the architecture and domain analysis, we also provide the user of the ARM with best practices for the deriving use case and application specific architecture seen in the figure. So this is the overall explanation of the dynamic view of the IoT architecture model, including several parameters like technical analysis, demonstrating implementation, ARM draft to ARM review, ARM derivation, domain modeling, function modeling. What is the main function of individual parameters we discussed in the last slide only. So next one, benefits of using ARM. So what are the benefits we are going to get by using of ARM architecture model? So here the first one here we have four, 1, 2, 3, 4. So the cognitive weight is when it comes to product development and other activities, an architectural reference model is on fourfold use here. So the first one, what is the first benefit we are going to get from the ARM? It aids in guiding discussions first, aiding guiding discussions since it provides a language everyone involved can use, and which is initially intimately linked to architecture and system, the uses of domain, etc. So this is the first benefit by using ARM. Next one, second one, the high level view provided by such as model is high educational value. Some of it provides abstract but also rich view of the domain. Such a view can help people to know the field with understanding the particularities in terms of the IoTs. This is the second one. Next, third one, the architecture reference model can assist IoT project leaders in planning to the work at hand and teams needed. For instance, the functionality groups identified in the functional view of the IoT system can also be understood as a list of independent teams working on the IoT system implementation. So this is the third benefit of by using AR. Next, the fourth one, the architecture reference model aids in identifying independent building blocks for the IoT system. Then it constitutes very valuable information. Which type of information? That is very confidential information, that is known as valuable information when dealing with the questions. It can deal with some questions and answer high level questions like system modularity, processor architecture, third vendor options, reuse already developed components. Like these are some question type valuable information it having. So in this domain also, the one of the benefit of architecture reference model. So these are the four benefits why we are using ARM model: first, second, third, fourth. So the first two can deal with the guiding discussions. Next, the second dealing with high level educational values. Next, the third one, it can deal with IoT project leaders work hand. Next, the fourth one, valuable information, deals with valuable information. So these are the four benefits. Next, usage of standardized architecture methodologies for the development of IoT ARM. So here, this is methodology. This is aspect adapted in our work. So just in real work, the table it can summarizes how we use ideas borrowed from standardized architecture methodologies for our work on the higher abstract level of architecture reference model. So here, the first methodology, aspect oriented programming. So that is for level in level the declination of functionalities by aspects. This is embedded in the concept of functionality group. So the main work our work is based on the aspect oriented programming, so like functionalities by aspects. Next one, model driven engineering. So that is one of the methodology. So for our work is general concept of transformation from a generic to a more specific model. We use this concept for describing and developing our best practice. Next, to pattern based design. The third methodology is pattern based design. So we will test the efficacy of the method upon deriving a concrete architecture as a best practice to test case. So this is the third one. Next, fourth one, views and perspectives. We adapt to the concept of views and perspectives for derivation of the IoT reference model. We arrange all the aspects of our reference architecture according to the perspectives. The same done for the utilized unified requirement. So these are the some standard architecture methodologies for the development of the IoT architecture. Aspect-oriented programming can deal with the functionality of the aspects. Model driven engineering can deal with describing and developing of best practices, and pattern based recognition. Just it can deal with machine learning pattern recognition system like that. So we will efficacy of the method upon the concrete architecture. Next, views and perspectives. It can deal with some unified requirements of the system. So these are the four methodologies as per work. So these are the references. This is the about IoT reference model ARM with complete description and types. Let's continue with the next class. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.